Hello, welcome to homework 7.03. This assignment's going to have just a whole bunch of systems of equations, and we're going to get to solve them in different ways. We've sort of talked about the three ways of solving. There's graphing, elimination, and substitution, and we're going to get to do all three of those on this homework, so I know you're pretty excited about that. All right, let's take a look at this first one. 3d minus 2e equals 6, 5d plus 7e equals 41. All right, so the first thing we have to figure out is just what way do we want to solve this? All right, well, we're probably not going to use graphing because we don't have a graph to actually graph it. So that leaves elimination or substitution. The general rule is if you can get a letter by itself super easy, like you only have to subtract a number or you only have to add a number, then a substitution's not a bad choice. If you have to divide to get a number by itself, so like here we'd have to divide by 3 to get the d by itself, here we'd have to divide by 2, divide by 5, divide by 7, substitution's probably not a great choice because there's a good chance you're going to end up with some fractions that just become a hassle to actually do the substitution with. So this one is going to be an elimination problem, all right? We'll see the d's are already lined up, the e's are already lined up, and we don't have a letter that has a positive 1 in front, which means we'd have to divide, so substitution is just not a great choice. So if we're going to do elimination, we need to get opposites. Right now we don't have opposites because we have a 3 and a 5, we have a 2 and a 7. All right, so we have to pick which one we want to get rid of, the d's or the e's. I'm going to go with the e's because we already have a negative and a positive, so I don't have to make one of them negative. So I'm going to put both equations in parentheses. The number that's in front of this e is going to come up here, so I'm going to end up multiplying by 7. And then the number that's in front of this is going to come down here. Now, a lot of times kids want to make it a negative 2, but we kind of talked about how you have to ignore the signs. All right, it doesn't matter what the signs are because ultimately you need one positive and one negative. So 7 times negative 2 is going to give us negative 14. 2 times positive 7 is going to give us positive 14. All right, if we had made this negative, we would have ended up with 2 negative 14s, and then we wouldn't have had opposites. You know, the rule of thumb is you only want one of the 4 signs to be different. So we've got a positive, a positive, a positive, so we only want one to be different, and there it is, the negative. You could also have negative, 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 and then you'd only want one of them to be positive. But for this problem, it's positive, 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 with just one negative. So now that we have those numbers out, we actually have to do our distribution. So 7 times 3 is 21d. 7 times negative 2 is negative 14e. 7 times 6 equals 42. And then we'll do the same thing down at the bottom here. 2 times 5 is 10d. 2 times 7 is positive 14e. There's our opposites. And then 2 times 41 equals 82. All right. Now that we have opposites, now we can actually do the elimination when we add our equations together. 21 plus 10 is going to be 31d. Negative 14 plus positive 14 is going to cancel out. And then 42 plus 82 is going to give us 124. Okay. So at this point, we're ready to solve. Just divide by 31, and you're going to get d equals 4. All right, so we've got d equals 4 right there. All right, now we're not done yet because we still need to find our other variable. We found d, but we still need to get e. So we have to pick one of these two. I'm just going to go with the bottom one. Doesn't really matter which one you pick. So I've got 5d plus 7e equals 41. All right, I've got that right over there. I'm going to take this d equals 4, and I'm going to plug it in. So now I have 5 times 4 plus 7 times e equals 41. 5 times 4 is 20, plus 7e equals 41. Subtract 20, subtract 20. 7e equals 21. Divide by 7, divide by 7, e equals 3. All right, so now I've got both of my letters, so I've solved the system. Never a bad idea just to go back and check these. So we'd bring out our calculator. D is 4, E is 3, so we would just plug them in. 3 times 4 minus 2 times 3, and hopefully we get 6, and we do. And then for the second one, it would be 5 times 4 plus 7 times 3, and hopefully we get 41, and we get 41. So we are good to go on this first problem. All right, let's take a look at the second problem. Y equals 4x minus 16, y equals negative 2x plus 2. So again, we have to think to ourselves. Probably not going to graph because I don't have any graph paper. I'm either going to do substitution or elimination. Now on this one, we can see that we already have letters by themselves. All right, y is by itself on both of these. So that makes it really easy to do substitution. Y equals 4x minus 16. So I can take this 4x minus 16 and substitute it in anywhere that I see a y. All right, so I'm going to get a new equation that's 4x minus 16 equals negative 2x plus 2. Hold on, my pen's kind of dying on me here. Let's see. All right, 4x minus 16 equals negative 2x plus 2. All right, and now I just have an equation that I need to solve. So I've got variables on both sides. I need to get them to the same side. So I'm going to do plus 2x, 6x minus 16 equals 2. I'm going to add 16 to both sides. 6x equals 18. Divide by 6, divide by 6. X equals 3. Okay, so I've got the first one there. Now I need to find y, so I pick one of these two. Just go with the one on top. So y equals 4x minus 16. I'm going to take this 3, and I'm going to plug it in for my x. So this is going to become y equals 4 times 3 minus 16, or y equals 12 minus 16, or just y equals negative 4. All right, so then our x is 3, our y is negative 4. So if we actually were to graph these lines, they would intersect at 3, negative 4. That's the coordinates where they would intersect. And again, we can check this as well. We have 4x minus 16, so it would just be 4 times 3 minus 16, and that should be negative 4, and it is. And then we have negative 2 times 3 plus 2, and that should equal negative 4 as well, and it does, so this one checks out, and we're good to go. All right, let's flip it over to the back. Number 3, 2a minus 5b equals 38. A plus b equals negative 2. Now this is one that I could really do either approach for. If you really like substitution, it's pretty easy to get the a or the b by itself. You could either subtract b from both sides, or you could subtract a from both sides. It's an easy substitution. If you like elimination, it's also good for elimination because the letters are all lined up. We just need to make opposites. We've got a negative 5 here. If we could turn this into a positive 5, we'd be good to go. We've got a positive 2 here. If we could turn this into a negative 2, we'd be good to go. So either way, it's really personal preference on a problem like this. I'm going to go with elimination because there is another substitution problem down below, so that'll give us a mix of both. All right, so you pick which letter you want to get rid of. Again, I'm going to go with the B just because I already have a negative and a positive there. So if I want the opposite of negative 5, I need a positive 5. So basically all I need to do is multiply this bottom equation by 5, because 5 times 1, remember there's that 1 there, is just going to give us the positive 5 that we need. So I'm going to multiply this one by 5, which is coming from up here. And then if you wanted to, you could think about it as like, oh, you are bringing this 1 up here to multiply this top one, but multiplying by 1 isn't actually going to change anything. Like 1 times 2 is still 2, 1 times negative 5 is still 5, 1 times 38 is still 38. So you can write it out there if you want. Just understand that it's going to be exactly the same as it was before, because multiplying by 1 is not going to change it. We call that the identity property in math. But down here it will change. We've got 5 times a is going to be 5a, 5 times 1 is going to be positive 5b, and 5 times negative 2 is going to be a negative 10. All right, this gives us our opposites, so we can add these together. 5 plus 2 is going to be 7a. These are going to cancel out. 38 plus negative 10 is going to be 28. We can divide both sides by 7, and we're going to end up with a equals 4. Okay. So this is a good start, but we still need to find the other letter. So let's use this equation because this one's a whole lot shorter. A plus b equals negative 2. Take the 4 and plug it in here. So we get 4 plus b equals negative 2. Subtract 4 from both sides and get b equal to negative 6. Okay. So again, always a good idea to check these. So let's see, we've got 2 times 4, because that's our a, minus 5 times negative 6, because that's our b. Hopefully it's going to be 38, and it is. And then we've got 4 plus negative 6, and hopefully that's going to equal negative 2, and it does, so we can be confident that we got the right answer here. All right, number 4, consider the system of equations. Solve this system graphically by using the grid shown at the right. All right, so we have 2 equations here, and we're going to graph both of them. Now, sometimes these y equal negative 3 type equations or x equal negative 3 throw kids for a loop. Here's the way that I think is maybe the easiest to think about it. Make a table, so x and y. Now it tells you that y equals negative 3. So in your y column, just make a bunch of negative 3's. All right? I usually say 4 points, so just make 4 negative 3's. Now you might be saying, all right, but what do I do for the x? Well, here's the beautiful part. Just put whatever you want in for the x. Don't pick really big numbers, because then you have to count a lot of squares. Just be like, all right, I'll do negative 1, I'll do 0, I'll do 1, I'll do 2. Doesn't matter what you pick. You can literally pick anything as long as the y is negative 3. So when we go over here and graph these, remember x is left to right, y is up and down. It's going to be negative 1, negative 3. It's going to be 0, which means I don't go left to right at all, negative 3. It's going to be 1, negative 3. It's going to be 2, negative 3. So you can see it's just going to be a horizontal line crossing the y-axis at negative 3. So there's our y equals negative 3 line. Okay. Now the other one, you have 2 choices. You either go to your y equals, you type in negative 2x minus 5, you go to second graph, and you look at your table, and then you pick, 4 of these points. You plot your points, you put them on the grid. The other way you do it is you say, all right, this negative 5 here is my y-intercept. So that's where I'm going to start, down at negative 5. And this negative 2, I could write as negative 2 over 1. And that right there is my slope. All right, so in that case, it would be, all right, I'm starting down, 1, 2, 3, 4, 5. And then since the slope is negative, it would be down 2 over 1. That takes me off the grid, but I can also do the reverse and go up to back 1, up to back 1, up to back 1, up to back 1, up to back 1. I mean, the important thing is you're going to notice that as we look at our line left to right here, it's sloping down. That's kind of the trademark of a negative slope, is that when you look at it left to right, you're going downhill. So this is y equals negative 2x minus 5. The solution to a system is where the two lines intersect. So we can see that that right there is the point x negative 1, y negative 3. So the solution would be negative 1, comma 3. Now part B says solve the system using substitution. All right, so this should give us the same answer because we've been saying all along it's your choice which way you want to do it. You'll get the same answer. This is our chance to prove that. So we have y equals negative 3 and we have y equals negative 2x minus 5. Okay, so I know what y equals. It equals negative 3. So we're going to take it and we're going to plug it in there. So I get negative 3 equals negative 2x minus 5. I'll add 5 to both sides and get 2 equals negative 2x. I'll divide both sides by negative 2 and I will get that x equals negative 1. So I knew at the start that y was negative 3. I got that x is negative 1. Negative 1 comma negative 3. It's the same exact point that I got up here, negative 1, negative 3, negative 1, negative 3. So that shows me that I'm in fact getting the same answer. Okay, so that wraps up this homework. I hope this was of some help and have a good day.